Alright, we're going to go through some problems that you would face in 9.2. Remember, you're testing a claim about the population proportion. So the acronym we're going to use this time around is PHANTOMS. P stands for parameter of interest, just like we did with panic. Here we have to state what our null hypothesis and what our alternative hypothesis is. You're going to go ahead and test those three assumptions, whether they're random, normal, or independent. And then you're going to name the test. For 9.2, you're always going to use a one proportion z-test. Then you'll go ahead and find the test statistic, then get your p-value, and then decide whether you should reject or fail to reject your null hypothesis, and then state your conclusion. I know there's an extra t in there. Hopefully you picked up these materials yesterday in preparation for the snow day. If not, they'll be posted on Blackboard for you to go ahead and print out on your own. So this is the study guide for it. On the back of the study guide there is a problem. So we're going to keep this in close proximity so that we can go ahead and follow the PHANTOMS set of letters here. So the first part, let's go ahead and read the problem out. So on shows like American Idol, contestants often wonder if there's an advantage for performing last. To investigate this, a random sample of 600 American Idol fans, and I'm just going to highlight a few things. So 600 is our sample size, is selected to view audition tapes of 12 never-before-seen contestants. For each fan, the order of the 12 videos is randomly determined, so it's a random. Thus, this is also a random sample up here. Thus, if the order of performance doesn't matter, we would expect approximately 1/12 of the fans to prefer the last contestant they view. In this study, 59 of the 600 fans preferred the last contestant they viewed. Do these data provide convincing evidence that there's an advantage to going last? So 59 out of 600. Alright, so P, we have to figure out what is the parameter of interest. So let's go ahead and state I am testing and it doesn't say the significance level. Usually they'll tell you alpha is equal to 0.1 or something else. So if it's not stated, you're going to go ahead and assume 0.05. Adding significance level, that's alpha, 0.05. The true population proportion P of American Idol fans who prefer the last performance they see. Okay, so that whole entire sentence is all for just the first part. So H is pretty much stating the hypothesis. So for here, if they see 12, they're going to prefer the last one, so it's 1 out of 12. So my null hypothesis is P is equal to 1/12. Okay. Let's see. So it says, do these data provide convincing evidence that there is an advantage to going last? So if there's an advantage, that means our proportion is going to be greater than 1/12. Notice, since it's greater than, it's going to be a one-sided alternative hypothesis instead of just two-sided one. If it was not equal to, that would be the two-sided one. Alright, so A, very much, it stands for assumptions, so we're going to go through our three conditions that we have to test for. Is it random? Yes. It's stated in the problem that the sample is random. Alright, Second thing we're going to check to see if it's normal. Remember, with normal, with proportions, you're going to go ahead and see if n times p is greater than 10, and also to see if n times 1 minus p is greater than 10. And the p that we're going to actually use here is your p naught. So I'm going to go ahead and put a p naught. Alright, so our sample size is 600. 600 times 1/12 and 600 times 1 minus 1/12, so it's 11/12. So these are successes and these are failures. Let's go ahead and calculate that. So this would be 50, definitely greater than 10, and this would be 550. Okay, notice these two numbers add up to the sample size of 600. So yes, this passes that normal test. Are they independent? So our sample size has to be 1/10. Has to be less than 1/10 of our population. So if I multiply 10 with our sample size, is that less than our population? So that makes we have to have more than 6,000 American Idol fans. And I would just go ahead and state there are more than 6,000 American Idol fans. Alright, so it's passed all three tests. We're going to go ahead and name what our method, since all conditions have been met. I'll use a 1 proportion z test. This is because, remember, if we're using z, that means we're using the normal curve. Alright, t. We're going to go ahead and find our test statistic. And remember, this was in the previous video. It's pretty much z is equal to p hat, that's our statistic, minus p naught over the standard deviation of the statistic. So we're going to go ahead and put in p naught times 1 minus p naught all over n. Alright, so you always want to write the form that you're going to use. Then we're going to go ahead and do this by filling in the numbers. So 59 out of 600. We do that on our calculator. Let's see. Gives us 0.098. So we use that. 0.098 minus 1 divided by 12. 0.083 all over square root of 0.083 times 1 minus 0.083 all over 600. Okay, so let's plug this into our calculator. I'm going to go ahead and actually keep using 1/12, or you could store what I just did in x. So we'll do square root of x times 1 minus x all divided by 600. Okay, now that's the denominator. The numerator, I'm going to go ahead and take 59 600ths, sorry, it's a division, subtract a 12th from that. Oh, I should have stored the other one. Divided by this number. Alright, so we get 1.329. Remember, our z-scores only get rounded to 2 decimal places, so we're going to use 1.33. That's our test statistic. Now we're going to go ahead to go to O. We have to figure out what the p-value is, and that's pretty much the probability that your z is going to be greater than 1.33. Okay, which is also equal to 1 minus the probability that your z is less than 1.33. Alright, this is the point where you would go ahead and use your z-score table. Once you figure it out on the z-score table, it's 1 minus 0.9082. So my probability is 0.0918. Okay. You definitely want to go ahead and draw your normal curve. So I'm going to do this off to the side right here. So here's my normal curve. Right here would be that 1/12. Okay, so if this was 0, okay, on the standard normal curve, 1.33 would be right here. And we're pretty much looking at this shaded region here. Okay, it's greater than, so we're going to go ahead and shade in the area that's greater than. So that's our 0.0918. And I'm going to put a p-value right above it. Okay, so the last two parts, we're going to make a decision. Our decision is, well, our p-value is greater than our significance level. So we actually don't have enough evidence to go ahead and reject our null hypothesis. So 0.0918 is greater than 0.05. So we fail to reject H0. Alright, if we look at our study guide, there's a huge portion for the S, which is pretty much stating your conclusion. You do definitely want to go ahead and make sure that you write everything because it's a full explanation of your results. So let's go ahead and write it out here. There is not sufficient evidence at a 0.005 significance level to show that the true proportion of American Idol fans who prefer the last performance they see is greater than 1/12. Okay. If the true proportion of fans that prefer the last performance really is 1/12, then the probability of observing a value as extreme as the one actually observed so in this case 59 out of 600 is 0.0918. This is likely to have occurred by chance alone. Alright, so notice it is longer than a panic problem. but it covers the 4 areas that you'll have to go ahead and show. It has to state, so P is stating as well as the age. Plan is the A and the N. Do the calculations is T and O. And then conclude is the last 2 letters. Alright, so it's a lot of writing, but it's going to get you through the entire process during your AP exam. Alright, enjoy the rest of your snow day.